Okay, good morning. We're going to be looking at some problems here, and we've been given this condition that sine of 30 is 1/2. I've drawn that condition here, 30 degrees, so the height 1 over the hypotenuse 2 yields an x of square root of 3. So we have x squared plus 1 squared equals 4, or 2 squared. And that's x squared equals 4 minus 1, and x equals plus or minus square root of 3. And in this condition, because it's in the first quadrant, we know that it is plus square root of 3. Now, with some of these problems, we know that, for example, that 150 is equal to 90 plus 60. So that's 150, and that would yield a mirror image of what we've got here. With an angle of 30 there. This is 60. So this whole angle is 130. This would be negative square root of 3. This is 1 and 2. And so the sine of 150 is equal to 1/2. So that's our first solution. Here we have sine of 210. So 180 plus 30 is 210. So 210 is 30 degrees below. It's this complementary angle here. Let's erase this. And that would be this angle. That's 210, but this is 30, or really minus 30. We have minus 1, 2, and minus square root of 3. And the sine of that angle would be sine of 210, which is equal to negative 1 over 2. So that's minus 1/2. Now some of these are a little easier to use, let's say, identities. We could take a look at this one first, and we say cosine of 120 is equal to the cosine of 90 plus 30. And so we can use a double angle formula for that. So cosine of 90 plus 30 is equal to cosine 90 cosine 30 minus sine 90 sine 30. We know the cosine of 90 is 0. So that term drops out. So cosine of 120 is equal to minus sine of 90 is 1 times 1/2. So that's equal to minus 1/2. Minus 1/2. And let's just give that a check. And that's exactly right. Sometimes that's a little easier to use than to try and figure out the angles, because when we look at this cosine of 120, we go like this, and this is 120 here, which is 90 plus 30, so this angle here is 30. And so that's -1, and this is square root of 3. Whoops. This is 60. And so this is 30. Opposite over, so that's, so the cosine of 120, you see it's a little more difficult to, it's the same as 120 is the same as sine of minus 30, and that's equal to minus 1/2. But that is a little harder. It's not as easy to arrive visually as just applying the double angle formula. Now 330 is simply, let's erase this business. Okay, 330 is minus 30. So we just draw that off of this. And so that's minus 30. And so this is -1, 2, and the square root of 3. And we want the cosine of that. So that is square root of 3 over 2. So cosine of 330 is equal to the square root of 3 over 2. Square root of 3 over 2. Losing my 270. Now 210 is 180 plus 30. So we have the tangent. Let's see, we got to draw the complement again. This is 30. Okay, this is 2, -1, And this is square root of 3, negative. And the tangent of 210 is that over that. So that's equal to negative 1 over negative square root of 3, which is equal to 1 over the square root of 3, or square root of 3 over 3. And let's give that a check just to make sure. Okay, we've got 210, and we have tangent. That's 0.5777. That's equal to tangent 210 is equal to 0.57735. And let's see what this is equal to. So we got 3 square root divided by 3. And that's the same, 0.57735. So we worked that out correctly. And we have square root of 3 over 3. These are useful to know when you try and work these out. Sometimes they can be a little confusing, and that's why it's a good idea to have another way of checking. Like for the cosine of 120, I use the double angle formula. 300. Well, 300 is 360 minus 360, 60 minus 60, and that's 30 degrees, or 270 plus 30. So we're in this quadrant. And we want the tangent. So let's try and, okay, so we've got, it's basically minus 60. Minus 60. So that's, we're gonna make some room here so I can write. So this is 30. Okay, so we want tangent of 300 is equal to the tangent of minus 60, which is equal to the sine of minus 60 over the cosine of minus 60. Well, the sine of minus 60, this is, okay, this is going to be the square root of 3. This is 2. And this is 1. So that's equal to, and that's minus So we have minus square root of 3 on 2, and cosine of minus 60 is 1/2. These 2's cancel, and that's equal to 300 is equal to the negative square root of 3. Now let's give that a check. Okay. Okay, let's see. 300 tangent 3 square root, and that's correct. So this is minus square root of 3. We already just did the sine of minus 30. Well, let's do it again. Minus 30 is just the mirror image of this. Boy, I'm no good at that, am I? Okay. Alrighty. This is minus 30. This is 30. That's minus 1, 2, and this is the square root of 3. So sine of minus 30 is equal to negative 1 on 2, and that's minus 1/2. The cosine of minus 30, cosine of minus 30 is equal to square root of 3 on 2. So that is square root, square root, boy, I'm having trouble with that, aren't I? Square root of 3 on 2. And last, tangent of minus 30, which is simply minus sine of minus 30 over cosine minus 30, and that's equal to minus 1/2 over square root of 3 on 2. Those go out, and that's equal to minus 1 on the square root of 3, or square root of 3 on 3, negative sign. So that's minus square root of 3 on 3. And so we have them all solved. Again, it's sometimes easier to use the double angle formula, and sometimes it isn't. So like in the case of, let's say, sine of 150. Let's take a look at the sine of 150 using the double angle formula. So the sine of 150 where 150 is equal to 90 plus 30 plus 30. So let's write that out. Is equal to the sine of 30 plus 90 plus 30. And if we use the double angle formula, we have that equal to sine of 30 times cosine of 90 plus 30 plus sine of 90 plus 30 cosine of 30. And we know that the sine of 30 is equal to 1/2, and that leaves us with the double angle formula for the cosine, so that's cosine 90 cosine 30 minus sine 90 sine 30 make that a square bracket plus, and that is this, see, cosine 30. We have 1, 2, square root of 3, so the square root of 3 on 2 times sine 90 cosine 30 plus, and we're out of room, okay, plus cos 90 sine 30. But the cosine of 90 is 0. And so here we got 0, and that's equal to 0. So we have 1/2. See how cumbersome this is getting? Times minus sine of 90 sine 30 plus square root of 3 on 2 sine of 90 cosine of 30 and these terms drop because they're 0. And so that is equal to 1/2 times -1 times 1/2 plus square root of 3 on 2 times 1 times square root of 3 on 2. So we have -1/4 plus 3 on 4, and this is equal to 2 on 4 equals 1/2. So sine of 150 is equal to 1/2, and that is a little bit cumbersome when you use the double angle formula. Sometimes it makes things easier, sometimes it makes it harder, but you get the right answer if you're careful and you watch your terms. And it's all by definition. It's all going back to the rudimentary definitions of what sine and cosine means. So, let's take a look at another problem. I got my screensaver set too short. Alright, let's take a look at another problem. Alrighty. Here's one that I think is pretty nice. Here, we're given this situation. We're given a point. We're given, this is, let's see if I can read it. X is minus 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5, 7, 8, 9. So this is minus 5, and we want 0.866, so we can say it's approximately 0.866, somewhere there. And there. So this is our point. That's our point. And that is -5 and 8.66. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'll draw the situation. Okay, so we got to find theta. Okay, so this is -5. This is 8.66 is y. And so what's the hypotenuse? R. So we have 8.66 squared plus -5 squared equals r squared. And rather than calculating it, I'm going to do 8.66 times 8.66, and we got 70. It's approximately 75. If you round it up, it's 75 plus 25 equals r squared. That's equal to 100, so r equals plus or minus 10. Oops, I'm sorry. 10. So this is 10. I think that was one of the questions. We wanted to find what r was. So the question was, what is r? Well, we've got r equals 10. Okay, so we've got an alpha here, and we have the sine of alpha. Sine of alpha is equal to -5 over 10 is equal to -1/2. So that's 30 degrees. Alpha is equal to 30 degrees. And therefore theta is equal to 120. Because you have 90 degrees plus 30, 120. And let's see what we got. That's the answer. So we solved that problem. Let's take a look at another problem. That might be interesting. Let's look at here. Here's a nice one. We're going to take a look at a triangle. All right. And we're given that this side is 8, this side is 12. We know that this angle is 40 degrees, and we're given C, the angle C, and the angle B. So what we're given is find angles C and B. We also want to find C, the base, and Y, the height. And that is this vertical drawn from that vertices, and this is Y. Okay, so let's get right to it. We have one tool that we can use, which is the law of sines. So we have 12 over the sine of 40 is equal to 8 over the sine of B. So we have sine B is equal to 8 divided by 12 sine 40. And 8 and 12 both are divisible by 4, so we can say that is 2/3. And sine of 40, we have 45 is square root of 2 on 2 is the sine of 45 degrees. So it's a little smaller than, it's a little smaller sine of 40 is a little smaller than the square root of 2 on 2. So, well, we'll see what it is. So, equals, and let's sine of 40 is 0.64 is 2/3 times 0.643. And what was 45 sine? 0.707. 0.707 was the sine of 45. So we'd be off by a fair bit if we used 45. It makes a significant difference. So when we look at this, we have 0.643 times 2 divided by 3 is equal to 0.429. So we say the arctan of that is equal to the angle B. So arctan of 0.429 is equal to, and let's take a look at the arcsine. That's equal to 25.38 degrees. So B is equal to 25.38 degrees. That means we have 180 minus 40 is 140 minus 25.38, and we're solving for C, so that's 10, 9, 9, 3, and that's 6, 2, 6, 4, 1, 1. So C is 114.62, and we have A is 40 degrees. And you add them up, and that should be 180 degrees. We could also do it another way. We could actually solve for that using the law of sines, which we can do once we have C. So actually we are going to use the law of sines for C. We have 12 over sine of 40 is equal to C over the sine of C. Let's see. But let us first get, okay, so we have x and C minus x, and x over, let's see, 8 is equal to cosine of 40 degrees. X equals 8 cosine 40 degrees, and that's equal to, let's 40 and cosine times 8 equals 6.13. So x is equal to 6.13, and we also have, make a little room here, we also have y over 12 is equal to the sine of b, which is 25.38 degrees, and that's equal to 12 times sine of 25.38 degrees, and y is equal to, let's 25.38 sine times 12, and that's 5.14. So y is equal to 5.14. So we've got 1, 2, and 3 of the 4 that we need. So c minus x over 12 minus x over 12 equals sine or cosine of 25.38 degrees. C minus x equals 12 cosine. There are a number of ways we can get the same answer. So just because I happen to elect that method doesn't mean it's necessarily the preferred way. Let's see, 25.38 cosine times 12. Okay, so c minus x is 10.8. Okay. So c minus x is 10.8, and we know what x is. So c minus x equals 10.8, but x is equal to 6.13 equals 10.8, and c is equal to 10.8 plus 6.13, 10.8, 6.13, 3961. So c is the last thing that we're looking for, 0.93. And we could say it's approximately 17. So let's see, how did we do? Let's take a look at the solutions that we got here. Yes, we got y equals 5.14, that's correct. 114.63, 25.38. Okay, so we got all of the answers, 16.97. So we're off a little bit. It's a matter of rounding off. Where did you round off? So we solved that problem. We got other problems that are similar, and we can use some nice methods for that. Let's take a look at this here. We've got another triangle. Let's do this. All right, so we're given that this is 60. We are given that this side is 6. We have A. We have the base, which is given to be 8. And we have an angle alpha. We have the vertical, we'll call H this time. And we have phi, and that's a 90-degree angle. So we are to find y, x, a, b, alpha, and phi. Okay, so basically this divides that into x, and all right, so now we have our problem defined. We're to find h, x, a, b, alpha, and phi. So we are to find it b, a, h, phi, and alpha. And so the first thing we can do is we say h over 6 is equal to the sine of 60 degrees. And that's equal to 6 times the square root of 3 on 2. And that's equal to 3, the square root of 3. So we got one already solved. 3 times the square root of 3 is the height. Now, h over 9, h over 9 is equal to 3 square root of 3 over 9 equals the sine of alpha. And that is 3, so we have sine alpha equals square root of 3 on 3. So alpha equals the arc sine of square root of 3 over 3, and that is, and we can get that in 1 second, 3 square root divided by 3 equals, and we want the inverse sine. Inverse sine, and that's 35.26 degrees. So we got our second answer. So alpha is equal to 35.26 degrees. Here we want phi. Whoops. Phi is equal to, well, we don't have to do much there. That's a right triangle, so phi 60 plus phi equals 90. Phi equals 30. So that's 30 degrees. Let's see, what else did they want us to find? They wanted us to find A. We could find A any number of ways now. We can use the law of sines, we can use Pythagorean Theorem, we could use all sorts of things here. Let's use the Pythagorean Theorem to find x. So we have x squared plus h squared equals r squared, 6 squared. But h is that, so x squared plus 9 times 3 equals 36. X squared equals 36 minus 27, and that's equal to 9. So x equals 3. So we got x equals 3. And now b is 8 minus 3, so b is equal to 8 minus 3, which is 5. So we're already crossing off. We got h, x, alpha, phi, and we got b. The only one we don't have is a, and again we can use the Pythagorean Theorem. And we got a squared equals b squared plus h squared equals 5 squared plus, what's h? 3 times, because 3 square root of 3 squared is equal to 3 squared square root of 3 squared, which is 9 times 3. Just wanted to show where that came from. So we have 25 plus 27. 27, 25, that's 12, 5, whoops. 27, 25, 12, 52. So a squared equals 52, and a equals the square root of 52. So what is close to 52 that we know? Well, the 7 times 7 is 49. 7 squared is 49. 8 squared is 64. So it's between 7 and 8. And how far? Let's see. 52 is 49 plus 3. So it's not too far. Let's say 7.1. 7.1. We got 71, 749, 114. That's 50.41. That's not quite there. 7.3. 7.3. That's 9, 21, 21. Whoops. 49, 51. That's too much. That's 53.29. That's too much. So it's 7.2 something. So that's 7.2. Let's see where that lands us. 7.2, 7.2. That's 4 and 14, 14, 49, 50. So it's 51.8, getting close. 4. So it's 7.2 something. So A is approximately 7.2. Let's see what it is exactly. 52 square root is 7.21. 7.2111. So we weren't too far off with my approximation. So A equals 7.21, and that's approximate. So there we go. We solved another problem. We got all of the answers using our little toolkit of trigonometric functions, identities, definitions. See if I can find an interesting problem. And let us look. Here we go. Here's something. Okay. Here we're given the inverse sine of n is equal to theta. Express tangent of theta in terms of n of n. Okay, so we have theta, we have sine of theta equals n. So if we draw a right triangle, we have theta. Sine of theta is 1 over n, and x, by the Pythagorean Theorem, we have x squared plus 1 squared equals n squared. And so x squared equals n squared minus 1. And x equals the square root of n squared minus 1. So we have n squared minus 1. And that's because we know that sine of theta, which is the opposite over the hypotenuse, is equal to n. So, oh, wait a second, let's see. Yeah, 1 over the hypotenuse. I drew some, I went too quickly here. Let's take a look at this real quick. I did that too quickly. We redraw. We got theta. We know that the sine of theta is equal to n. Okay. H, R, X. So H on R is equal to n. And in order for us to get that, n, this has to be 1 over n. Okay, so, or we can say that this is n and this is 1. That's the better way. And x is squared plus n squared equals 1 squared. X squared equals 1 squared minus n squared. X equals 1 minus n squared. So we have 1 minus n squared. Okay, I knew something was a little screwy there. Okay, so we're given the problem trying to find the tangent of theta in terms of n. Well, the tangent of theta is y over x. So tangent theta is equal to n over 1 minus n squared. And that is the solution. So, what is, we got another problem here. What is cosine of the arc sine of n? Okay, so the arc sine of n is theta. So cosine of theta is equal to 1 minus n squared divided by 1. But that's all we need to express it as. And now we're given, let's see if they have another. Okay, it's a totally different problem now. Now, here we're given a problem. If tangent theta is equal to a over b, what is the sine of the arctan of a over b? Well, we know by definition that the tangent of a and b, and we could say that's theta, and this is a squared plus b squared. So the arctan of a over b is theta, and we want the sine of theta. That's what this says. And that's equal to a over the square root of a squared plus b squared. And they want then the cosine of theta, which is equal to b over a squared plus b squared. So we've got both solutions. We're really getting into the nitty-gritty of understanding the properties, characteristics of trigonometric functions and how they operate. We'll do one last problem, and we'll call it quits. After that, we've got a problem where we're given sine of theta is equal to 1/2. So if we draw a right triangle, and we got 2, 1, this is square root of 3, because we have x squared plus y squared equals r squared, and x squared equals, let's see, I have this backwards, I'm sorry. This is 2 and that's 1. And x squared plus y squared equals r squared, which is 2 squared is 4. So x squared equals 4 minus 1. X equals the square root of 3. So that's where we got that. And so we're asked to find the sine of the arc sine of 1/2. Well, we said that by definition the sine of theta is 1/2, so the arc sine of theta, the arc sine of 1/2 is theta. So we have that equaling to the sine of theta, and the sine of theta is 1/2. We're asked now to take a look at finding the tangent of the arc sine of 1/2. Oh, thank you. I'll take it. Oh, I got it, thanks. So, we remember, going back to our definition, that arc sine of 1/2 is theta, so tangent of theta equals 1 over the square root of 3, or it's equal to the square root of 3 over 3. So we have that solution. And what else? What can we do? What other problems have we got here that we can solve? All right, here's an interesting one. Derive tangent of A plus B equal to tangent A plus tangent B over 1 minus tangent A tangent B. Well, we can go to the definition of what a tangent is. So tangent A plus B is equal to sine of A plus B over cosine of A plus B. But we can use the double angle formulas. So that's equal to sine A cos B plus sine B cos A over cos A cos B minus sine A sine B. And we break this up, and let's do something here. We can take out, what do we have to get the tangent? Let's pull out the cosine. So we have sine A cos B plus sine B cos A, all divided by cos A cos B times 1 minus sine A sine B over cos A cos B. So we got part of it right there. This is, I pulled it out, and this is multiplied. A little algebra. And when we multiply across, here we have equal to sine A. I shouldn't have written so big. Sine A cos B over cos A cos B plus sine B cos A over cos A cos B, all over, now this is 1 minus tangent A and tangent B, because sine over B over cosine of B is tangent B. And these are out and that out, and we have tangent A plus tangent B over 1 minus tangent A times tangent B. So we derived by going back to the basic principles and applying the double angle formula. So that wasn't so bad. That's an interesting problem, using the definitions of sine and cosine. And let's see how much time. Well, maybe we got time for one more problem. All right. Okay. Tangent 2A. So we have tangent A plus A. So that is equal to tangent A, tangent plus tangent A over 1 minus tangent A times tangent A, and that's equal to 2 tangent A over 1 minus tangent A squared. But remember, cosine squared plus sine squared equals 1, and we got 1 plus tangent squared equals secant squared. So we can't use that identity. We'll just have to leave it at this. Or, I don't know, maybe, let's see, tangent squared equals secant squared minus 1. No, that's not going to work. Well, we'll just leave it like that. So this is our solution. So tangent to A, it's sort of the double angle formula for tangent. Let's see if there are any others here. We show, here we go, show that sine A, sine of 3A is equal to 3 sine A minus 4 sine to the third A. Well, let's get to it. We do the double angle formula. So we got sine of A plus 2A. That's equal to sine A cosine 2A plus sine 2A plus times cos A. So we have equal to sine A cos A minus sine A sine A plus sine A cos A plus sine A cos A times cos A. So now that we have everything expanded, we have cos squared A. So let's see what we have. Sine A times cosine squared A minus sine squared A plus sine A. This is 2 sine A cosine squared A. Let's write it a little bit more neatly. This is basically 2 sine A cosine A plus 2 sine A cos A, but that's multiplied by cos A, that's cos squared A. And so that is equal to sine A times 1 minus sine squared A minus sine squared A plus 2 sine A times 1 minus sine squared A. And we have sine A minus 2 sine cubed A plus 2 sine A minus 2 sine cubed A, and that's equal to 3 sine A minus 4 sine cubed A. And so we proved it just applying the double angle formulas. So I think right at this point we'll call it quits for this session of problem solving. If you have any problems that you would like to solve, why don't you leave them in the comments section, and I'll do my best to solve them for you. But we got more problems to solve, quite a few. We got some interesting stuff. We already did some curvature of the Earth stuff. I got other problems that we can take a look at. And so at this point, I'm just going to get back out of being fuzzy, and I'm going to say so long to everybody, and until the next video.